for students. We only have one learning target here in lesson 5, but it's a long one. There's a ton of examples, a ton of different variations that can show up here when we graph rational functions. And so this will be a rather long video. Maybe you can skip around to the parts that you absolutely need, but there was probably a good chance we didn't get through all of the examples in class, so maybe you can fill in the gaps with this video. So graphing rational functions. I guess first of all, what is a rational function? Well, a rational function would be in this form, like f of x is equal to p of x over q of x, where p of x and q of x are polynomials. Okay, so basically you got a polynomial on the top, you got a polynomial on the bottom. That makes for a rational function. The reciprocal function, or the parent function for rational functions, just goes like this: y, or f of x, equals 1 over x. And if I were to graph this, you would wind up with something. So, if x equaled 1, you get 1. So we got that point right there, and that's kind of an indicator that would help me graph the rest here. If x equals -1, I would get, well, -1. So I have another point over here, and that would be a good helpful point to help me graph this. So this is the parent function. This is what it generally looks like. Another one that you'll see today is f of x equals 1 over x squared. So this would be the reciprocal quadratic function, or parent function of that. And this one, well, here's how it would look. Some key points here. If I had 1 squared is 1, and 1 divided by 1 is 1. So that's kind of a key point there. But if I had -1 squared is +1, so it would also be +1. And these would be kind of some indicators, and it would kind of look like this, which is similar to that one. But then this one would be more like this. So there it is. All right, two things that you need to pick up today, so some very basic vocabulary, and that's vertical asymptotes and horizontal asymptotes. And hopefully you kind of already have an idea of what these are, but for this one, this right here is considered a vertical asymptote because the function will get infinitely close to this line, but it'll never actually touch it. And same down here, it'll get infinitely close to the blue dotted line, but never touch it. Over here, this one also has a vertical asymptote. Both of these will get infinitely close, but never touch it. A horizontal asymptote, same principle. And here we can see that we have a horizontal asymptote because it'll get infinitely close here to the x-axis. Same with this one, but they'll never actually touch. This one also has a horizontal asymptote in that it'll get infinitely close here. It'll get infinitely close as it goes this way, but it'll never touch the x-axis. And so just like how we had key points with other functions that would help us shift it left, right, up, down, the center of this asymptote, or where the asymptotes cross, is kind of a key point that'll help us shift functions, which is something that we do here at the beginning. So it says graph and then give the domain and range. So if I've got y equals -2 over x, what I would do is I would recognize that, well, this is just like the parent function, y equals, I guess, 1 over x, except that I'm going to have a stretch factor of 2, so it's going to be kind of like stretched out a little bit, and then it'll be reflected over the x-axis because that's what the negative sign does when I'm stretching, reflecting, and all that. So first of all, my x-intercept, or my vertical asymptote would be 0. X cannot equal 0. Okay, and so that should be plainly clear because, well, my denominator here is x, and so x can't equal 0. My vertical asymptote, or sorry, my horizontal asymptote is going to be right here. And so I'll just pick a couple of points to graph, pretending, well, just using that as my key point. So let's see, if I pick something like 1, x equals 1, I get 2, negative 2 over 1, which is negative 2. And if I pick something like 2, negative 2 divided by 2 is negative 1. And so there we go. And because I have a pretty good idea of what it should look like with the end behavior, I'm going to go ahead and draw that. And of course there's a second half, so I'm going to pick a couple negative numbers. So if x equals negative 1, I get negative 2 divided by negative 1, which is positive 2. And if I pick negative 2, negative 2 divided by negative 2 is positive 1. So when x equals negative 2, I get y is positive 1. And again, because I've got a pretty good idea of what the end behavior is, and I've got the asymptotes to kind of fence me in, I can graph a pretty accurate function. All right, let's try another one. This one over here, what can the domain, or I guess what is my domain? What can x not equal? Well, x can't equal negative 1. And so that is my vertical asymptote. So I'll just draw my dotted line here at negative 1. The horizontal asymptote still going to be the x-axis. And now, again, I'm just going to graph y equals 2 over x, pretending like this spot right here is the origin. So again, I'll just pick a couple things. X equals 0. X equals 0 means I would have 2 over 1, which is 2. And if I picked 1, I'd have 2 over 2, which is 1. And I can graph this out using the asymptotes as my guide. And there we are. And then I'll kind of flip it around. I'll do some numbers back over here. If I put negative 2, well, let's pick a better number than that. How about negative 3? If I do negative 3, I get 2. And then negative 3 plus 1 would be negative 2. So negative 3 would be negative 1. And then if I pick something like negative 2, well, we'll just piece it together here. And we'll finish it off. And there it is. All right. So that's graphing some of those simple ones. Let's graduate to doing a little something bigger. So here we've got a number of shifts. It's still the same as all the others. I'm going to shift this the opposite of the sign. I'm going to shift this the same as the sign. And so it means I'm going to go 2 to the left, and then I'm going to go, well, 1 down. And this is going to be kind of the crosshairs for my vertical and horizontal asymptote. And that'll help. And well, don't forget this one is actually one of those squared ones, so they're kind of both going to be on the same side. But I'm just going to graph y equals 1 over x squared, again pretending like this is the origin, picking a couple of points. So if I picked x equals 1, 1 squared is 1, 1 divided by 1 is 1. So I have a point right here. Negative 1 squared would be positive 1. 1 divided by 1 is 1. So I've got these. If that's enough to help you out and graph it, feel free to go ahead and do that. If you wanted more, maybe pick another value. Maybe pick 2. 2 squared is 4. 1 divided by 4 is 1/4. So over 2 up 1/4. And you'd have kind of a symmetric point over here at 1/4. So, again, using the asymptotes as a guide, you can fill this in and draw yourself a fairly accurate graph. All right, so that's graphing there. Domain and range, I forgot to do that on the last slide. We'll do it on this one. Domain Well, domain, what are all of my possible x values? Well, it'd be all real numbers, but x cannot equal, well, x can't equal -2. And the range, well, what can the range be? What could all my possible y values be? Well, it is all real numbers, but I can't do anything below -1, and I can't do -1 either. So we're just going to say y is greater than, strictly greater than, -1. All right. Now, moving on. Those were all kind of pre-canned to make them easy for you. There weren't really any polynomials involved here. So this is kind of the baby step leading up to graphing just any rational function by hand. So here it says find all of the asymptotes. And we're going to have to give you a couple of rules here. The vertical asymptotes are pretty easy. So let's just take care of those for each one of these. Okay. The vertical asymptotes is simply just going to be where, what the denominator can't be. So kind of setting the denominator equal to 0. What can x not equal? Well, obviously here it can't equal 1/2. So that's going to be a vertical asymptote. And it also can't equal -3. Okay, so these are your vertical asymptotes, x equals. Okay, and that's where you'd kind of draw your vertical dotted lines. Over here, x equals 3 is a vertical asymptote because x can't equal 3. And then over here, x equals 2 is my vertical asymptote because obviously x can't equal 2 would make the denominator equal to 0. So really, with this, the horizontal asymptotes are kind of the tricky part. And there's essentially 3 different situations, and you're going to see each one of those 3 different situations here with these 3 problems. And it all deals with the exponents. So here's the thing. My degree in the numerator is 1. And down here, if I expand this out, I'm going to wind up with 2x squared plus 5x minus 3. Okay, regardless, what I'm looking at here is the degree. Okay, and so if you have a situation where the numerator, the degree in the numerator is less than the degree in the denominator. So here, that's 1, that's less than 2. Okay, this means my horizontal asymptote is just y equals 0, or the x-axis. Okay, and that's basically what we saw in first, in all the cases in the previous examples, and so that's pretty common. Now there's 2 other cases here. And so the second case, you can see that the degree here is 1, and the degree here is 1. When the degree is the same, okay, what you're going to do is you're going to take the leading coefficients, and that is going to be your horizontal asymptote. So here, because the degree is the same, both 1, I take the coefficients, 2 divided by 1, which is 2. And so my horizontal asymptote is at y equals 2. It's the horizontal line that goes through the y-axis at 2. Now the third situation here is where the degree in the numerator is 1 larger than the degree in the denominator. So it's not smaller, it's not the same, it's 1 greater, and that is going to give you what's known as an oblique asymptote. It actually has no horizontal asymptote, it has an oblique asymptote. And, well, how do we find the equation for that? Because it'll have a slope, it's oblique. And so what you would simply do is you would do your division. So synthetic division, we would divide by x minus 2, and that means we got 2 here, and we got 1 Then we got 0 because we have a 0x term, and then 1. All right, so if we do this, we wind up with 1. 1 times 2 is 2. 0 plus 2 is 2. 2 times 2 is 4. Okay, and so in the end, if I were to divide this out, I would wind up with x plus 2, and I'd have a remainder 5 over, then x minus 2 right here. Okay? Essentially what's going to happen is we're going to ignore the remainder, and what we have here, what we have left over that we got from this piece right here, that is going to be the equation for our oblique asymptote. So y equals x plus 2 would be the asymptote, and it's going to kind of cut across at an angle. All right, so these are baby steps leading up to how to graph any of these rational functions by hand. All right, so there's a number of steps to graphing this by hand. And they're all fairly short. Number one, you need to find your vertical asymptotes, which we saw there. That deals with your denominator. And then you need to find your horizontal asymptotes, or I guess in special cases, your oblique asymptotes. And that deals with the degree, okay, which is what we just talked about in the previous slide. And then you got some easy steps here. You just need to find the y-intercept, okay? And that's when x equals 0. What does y equal? That's not going to be real difficult. Then you're going to want to go ahead and find the x-intercepts, okay? How do we find the x-intercepts? Well, that's basically, we're just going to look at the numerator. So set the numerator equal to 0 and solve. Okay, so we have many, many different strategies for solving polynomials now at this point. So whatever your polynomial is in the numerator, solve that for 0, and that's going to get you your x-intercepts. Step 5, find if it crosses the horizontal asymptotes. So there'll be some special situations where it's possible it could cross a horizontal asymptote, and that's going to be important for you to find. And then you're going to need to plot a few points, essentially one in each interval, and that's going to help guide you. And then step number 7, use your end behavior to fill in the graph. Okay, so we've got a number of different examples for you here, and so let's get to it. All right. This one right here winds up actually being a little bit complicated, so we'll go through all the steps here. What are my vertical asymptotes? Well, my vertical asymptotes are going to be where the denominator equals 0. And so, we would just go ahead and factor this guy. And so if I factor it, I wind up with, I believe, 2x minus 1 and x plus 3. And so that means my vertical asymptotes are at x equals 1/2 and negative 3. So I'll go ahead and draw that on here now. I've got a vertical asymptote at 1/2. Oh, man. All right, well, we'll get back to it. Vertical asymptote at 1/2. And then also a vertical asymptote at negative 3. So with the two vertical asymptotes, this will actually be most likely a case where I have something that breaks it, because I'm going to have 3 different sections, and so something might break the horizontal asymptote, kind of like we talked about. All right, step number 2, So 1, find the vertical asymptotes. We did that. Step number 2, the horizontal asymptotes. Well, how did we find the vertical asymptote or the horizontal asymptotes? Well, here the degree is 1, here the degree is 2. If the degree in the numerator is less than the degree in the denominator, it's just going to be the x-axis. And so I'll draw that in. So already I've got a pretty good idea of how this is going to shape up. Let's go with step number 3, find the y-intercept. Well, the y-intercept is the y value when x equals 0. And so when x equals 0, that would go away, these would go away, and I'd just be left with 1/3, or negative 1/3. So I'll draw that in. So I got that right there. It's not super helpful, but it is a key point, so we'll use that. Step number 4, find the x-intercepts. Where is this going to cross the x-axis? Well, remember the x-intercepts, and again, that would be a little bit weird in this situation because we have a horizontal asymptote at y equals 0. But we'll go ahead and we'll solve this. The numerator, x plus 1 equals 0. And so x equals negative 1. So I actually have a spot where it hits or crosses the horizontal asymptote, and I said, you know, that can happen here, especially when I have multiple vertical asymptotes. So x equals negative 1. Okay. Step number 5, can it cross the horizontal asymptote? Well, you know, I would check that. I would verify that by plugging this in and making sure I got an actual value. And that obviously does happen. All right, so step number 6, plot some points in each interval. And so, well, I'm going to kind of make a table here and then show the work off to the side. In each section, I'm going to want a couple of points that will help guide me. I'm looking over here. It seems like negative 4 might be a good spot to check out. So when x equals negative 4, what would y equal? Well, it's going to help to have this in factored form. That might speed up the process, so I'll rewrite that. That was x plus 3 and 2x minus 1. So if x equals negative 4, I'd have negative 3 on top. And then on the bottom, if I plugged in negative 4 to both of these, I would get 9. And so that gives me negative 1/3. Okay, so if x equals negative 4, y equals negative 1/3. And all right, that's another spot for me. Let's see, is that, well, yeah, we'll figure out some more points here. Now I need, you know, I've got 2 in the middle here, but I'm still kind of wishy-washy on how it could look. I'm going to check out what it would be at negative 2. So if x equals negative 2, what's going to happen? Well, I would get negative 2 plus 1 on the top. That would give me negative 1. And then if I plug in negative 2 down here at the bottom, I would get negative 5, which means I get positive 1/5 when x equals negative 2. Okay, so negative 2, I get 1/5. That's this point right here. And now I've got a little better idea. Again, I think with the asymptotes, I could probably piece it together. All right, and I'm definitely going to want maybe 1 or 2 points over here on the right side of this asymptote. And, you know, I think maybe one is technically to the right of 1/2. 2 would be also to the right. So I think maybe I'll just go ahead and pick 1. 1 seems good enough. So when x equals 1, what do I wind up with? I get 1 plus 1 is 2 as a numerator. And then when I plug 1 in for x over here, I'm going to wind up with, let's see, what would I wind up with? I get 1 plus 3 is 4. And then 1 here would give me 1, so I'd have 4 times 1, which is 2, or sorry, 4. So I wind up with 1/2. So when x equals 1, y equals 1/2. And so I got something like that right there. And I guess that could help me a little bit. I think it's going to be kind of a tight squeeze. But now for step 7, I'm going to use my end behavior. I've got a point here. And again, I kind of know that it's going to follow these asymptotes like that. And then over here, again, I know this one is going to cross. It's still going to follow those dots. So there's that. And then this one, I've got a dot here. And that's something that kind of helps me with that one. All right, so that's graphing a rational function. We've got many more to go. So here it is. Here is a situation where the degree is the same on both. And so I know that's going to be a little bit different situation. But let's just go ahead and start with step number 1. Go ahead and find those vertical asymptotes. Okay, so when I look at this, I see that I've got a vertical asymptote. Well, if I kind of factor this one winds up being a special case. This is x plus 4 squared. And so my vertical asymptote is going to be x equals -4. All right, well, that means I got my vertical asymptote right here. My horizontal asymptote, let's see, so step number 2, horizontal asymptote. Well, remember, this is the case where if they're the same, I'm going to look at the leading coefficients, and I just go ahead and divide those. So 3 divided by 1 is 3. Okay, so x equals 3 is my horizontal asymptote. And that's going to be a good guide for me here. Step number 3, we're going to find the y-intercepts. So we're getting a couple of points here. Again, the x terms would all go to 0, and so I'd be left with -16/16, which would reduce down to, let's see, divide them both by 2, and you'd get -3/8. So that's not a real clean number, but it is a helpful point nonetheless. So 4/8 would be about half, so a little bit less than half be right here. All right, so I got a point on the graph. Let's see, what else do we need to know? Step number 4 was your x-intercepts. So we're going to set the numerator equal to 0. And, well, let's see. If I factored out the 3, I would wind up with x squared minus x minus 2 equal to 0. So I just want to factor this trinomial, and let's see, I would wind up with x plus 1 and x minus 2. And so my two x-intercepts are going to be -1 and +2. So that does look a little bit weird. So the next step, so we got x-intercepts at -1, I guess -1 and +2. 5, we need to know if we cross our horizontal asymptote at all. Sometimes it'll be just a horizontal asymptote for one and not the other part. So what we're going to do is we're going to go ahead and basically take our horizontal asymptote, which is 3, and we'll just see if this whole thing works out. So we'd have 3x squared minus 3x minus 6 over x squared plus 8x plus 16. Set this equal to my horizontal asymptote, which is 3, and then solve. Solve for x and see if it actually hits 3 at all. So to solve this for x, I'm going to multiply the denominator here by 3. So that's going to leave me with, I'm going to factor out the 3 out of the numerator again. So I'd have 3, and then x squared minus x minus 2 is equal to 3 times x squared plus 8x plus 16. All right, well, the 3's would cancel out. And also, the x squareds would wind up canceling out. And I'd have negative x minus 2 equals 8x plus 16. And I want to go ahead and solve all this down, trying to shorten a little bit for time, skip to the end. X would equal negative 2. And so what does that mean? It means that kind of this part that's on this side of the vertical asymptote is actually going to cross the horizontal asymptote at negative 2. Whew. All right, step 6, picking some points. I got a pretty good idea what it's going to look like on the right-hand side of this one. It's going to come down, and then it's going to come back up, and then kind of come back over to that one right there. So that's what the right-hand side looks like. But what is the left-hand side? I need at least one point here to help me out. So let's go ahead and pick a number. Let's pick, well, I got a pretty good feeling negative 10 is going to be a decent number, even though that's off my line. So 7, 8, 9, 10 would be over here. And so I'm going to plug 10 into this function right here. Again, in the interest of time and space, when you plug x in for each of these, what we wind up with is 9. So I got negative 10, positive 9, and that would be up here as my guide point. So yeah, this one isn't real great for an 8 by 8 graph, but I think we could see that it would probably be something like that. All right, so that was another long one. Maybe some of these are going to be a little bit shorter. Taking a look at this rational function, well, I look at it, and again, this is the third possibility. The third possibility being that when I look at my degrees, this one is actually one more than that one. So that means I'm going to have an oblique asymptote. So I guess step number 1, what are my vertical asymptotes? Well, again, that's the easy thing to pick out. X equals 2. And so I've got a vertical asymptote right here at 2. Step number 2, figure out my oblique asymptote. Well, remember, how are we going to do that? Well, we're going to do the synthetic division. I'm going to put 2 over here. I'm basically just dividing these. My coefficients in the numerator, 1, 0, and 1. And now I just go ahead and finish off the synthetic division. I bring down the 1. 2 times 1 is 2. 0 plus 2 is 2. 2 times 2 is 4. And I got the 5. Right? So again, this is kind of like the one that we saw earlier. I'm going to wind up with 1x plus 2, and then the remainder is going to be 5 over x minus 2, but I just make that go away. And so y equals x minus 2, or sorry, x plus 2, is going to be the equation for my oblique asymptote. So I got a y-intercept of 2, I got a slope of 1, so up 1 over 1. And so my oblique asymptote is basically going to look like that. So now, how do we fill in the rest of it? Well, let's continue with our steps here. Step number 3, go ahead and find the y-intercept. So what's the y-intercept? Well, everything goes to 0, and I get 1 over negative 2. So that's negative 1/2. So that's a nice key point here. Do I have any x-intercepts? And so, well, x-intercepts, no, we don't have any x-intercepts here. Step number 5. Step number 5, verify that you do or do not. We don't, so we'll just kind of skip that. So we're heading down to number 6 now, and so we're going to want to find some key points that'll help us put this all together. Now I've got a key point right over here in my y-intercept, and so I got an idea that it's somehow going to be inside here, but I want some points to verify. So I'll draw my table. This one should be a little bit quicker to pick out some points. I'm going to pick x equals 1. When x equals 1, I get 1 squared is 1, plus 1 is 2, and 1 down here would give me 1 minus 2 is negative 1. And so when x equals 1, y equals negative 2. So there's a key point, x equaling 1, y equaling negative 2. That gives me even more confirmation of what this should look like. I might even go ahead and do negative 1 since these ones are pretty easy. When x equals negative 1, y winds up equaling negative 2/3. So that would be right about here. And I feel like that's probably enough for me to go ahead and use my asymptotes as a guide to graph that part. Now I got a good idea that the other part of my graph is going to be this one up here, but let's go ahead and confirm that. Let's pick some points. Let's pick 3. 3 would give me this sector over here. When x equals 3, y winds up being 10. So over 3, up 10, 7, 8, 9, 10. That's going to be a little bit off my graph here again, but that's fine. How about we pick one more just to give a little confirmation to our graph. When x equals 4, y winds up being 8.5. And so 4, 8.5, that'd be right about here. And again, I think that's probably close enough for me to be able to graph the other part, which would look like this. So remember, you got the asymptotes that continue on here. And there we go. All right, we got one more, but this one winds up being quick. Here we got another one of these situations where this is exactly one more than this one, but this is actually a special case because I can go ahead and actually divide these. This isn't simplified where the other one was. So if I took this, x squared minus 4 would be the same as x plus 2 and x minus 2. So hopefully you can see that's a difference of squares. Then I got an x minus 2 down here. Well, these cancel out, and I wind up with something like y equals x plus 2. The only thing is, I know that if I look back at the original, my x value can't equal 2. So what I'm going to do here is I'm just going to graph y equals x plus 2, y-intercept at 2. I got a slope of 1. The only thing is when x equals 2, it can't equal that. And that's actually called a hole. And so we kind of just draw a hole there. And this is the rest. All right, well, that ends the longest lesson in the history of lessons. All right, here's what you'd need to know. We scratched out this part. Let's just say this.